Today we're going to talk about solving quadratic equations by factoring. So we've talked about factoring in our previous unit and with different polynomials. Now we're going to look at quadratics. And remember, quadratics is a degree of 2, so it's a degree 2 polynomial. So let's get into this. So a quadratic equation is a polynomial equation of degree 2, which can be written in standard form. So standard form looks the same as far as an expression, except there's one added thing. B, C, equals 0. That's our new part of the standard form, and that's the difference between the expression and the equation. We have it set equal to 0. Like linear equations, quadratic equations can be solved to determine the value or values of x that make the equation true. We're not going to worry about the real world. I'm going to skip that to save some time for you. So we're going to talk about solving for the x values. Now, solving for the x values is where it's going to cross the x-axis. It's going to be our x-intercepts, our zeros. So wherever that it crosses the x-axis is our x values that make the equation true. So there are various methods to solve quadratic equations. If the polynomial is factorable, the following method can be used. And I will tell you, we're going to skip a part. Don't worry about the zero product property. And I believe it's one of your vocab words too. Don't worry about that. We're not going to talk about that. So if necessary, we're going to rewrite the equation in the standard form of ax squared plus bx plus c equals 0. Notice that I'm not saying, that's not another letter there, that's not another variable to say it can equal anything. It has to equal 0. So when we say rewrite it, you're going to have to rewrite by making sure that it equals 0. So if there's a number on that side, you're going to have to move it to the other side. You're going to factor the polynomial, and you're going to set each factor equal to 0, and then solve the equation for x. So don't worry, we're not going to talk about this. We're good. So solve each equation for x. Now let's show you what that means. So remember when we talk about factoring, we're going to look, our first step is to see what degree, what is our a? Is it a 1 or is it a number other than 1? Because that gives us two different steps. We also look for a greatest common factor. There's not one. So I'm going to go ahead and factor it. Notice it's in standard form and equal to 0. So our little table, I need it to be a product of negative 10 that adds to positive 3. A product of factors of negative 10 and a product of 3. So our products of 10 are 1 and 10, 2 and 5. Okay, so our product has to be negative. That means one of our numbers is negative. Our sum is positive, so that means my bigger number is going to be positive. So that means my smaller numbers are going to be negative. So now we add them together to see which one gives us a sum of 3. Negative 1 plus 10 is 9. Negative 2 plus 5 is 3. So our factors are negative 2 and 5. So our factors look like x minus 2 and x plus 5. So that's our factors. That's step 2 that we just did. Step 3 is we're going to set each of the factors equal to 0. X minus 2 equals 0. X plus 5 equals 0. So this is the new step. We did factoring before. Now what we do is we set those factors to 0, equal to 0. And now we're going to, step 4, solve for x. So plus 2 to cancel that out. Plus 2 on this side. X equals 2. I subtract 5 from both sides. We're doing the opposite, so that it cancels out there. X equals negative 5. So my solutions, my zeros, my x-intercepts are at x equals negative 5 and x equals 2. So those are our solutions to the quadratic equation x squared plus 3x minus 10 equals 0. Okay, let's practice another. All right, 5x squared plus 15x. And a lot of you might overthink this. I just had to stop the video and rethink it because I was overthinking it. So, factoring, it doesn't just have to be the factoring method that we just used, like I was trying to do with this one. We also need to remember greatest common factor. So we have a common factor of 5 and x. So I'm going to take 5x out, and that leaves me with x plus 3 equals 0. So I'm going to just take my two factors and I'm going to set them equal to 0. And I'm going to solve for 0. So I'm going to subtract 3 here. That cancels out. X equals negative 3. And this one, I'm going to divide by 5. That cancels out. X, 0 divided by anything is still 0. So my solutions, my zeros for this equation is x equals 0. Well, if you put them in numerical order, it's negative 3 and then x equals 0. On the IND and exit tickets, I think you have to do it on this tickets too. You can put them in either direction. I have it where it will count both. If you want to figure out and practice number 4 on your own, I will tell you that the correct answer is x equals negative 3 and x equals negative 4. So if you can try to practice that on your own and try to get the same solutions. It says, using your graph calculator, graph the equations from questions 2 through 4. Where do you find the solutions to the equations on the graph? The solutions are the zeros or x-intercepts. Zeros or x-intercept. The graph on the right shows the function y equals 2x squared minus 3x minus 9. Use the graph, estimate the zeros of the function. So looking at the graph, that is where our zero's at. It looks like a negative 1.5 here, and I'd say almost 3 here. So I'm saying that's my estimation of the zeros. Now we're going to write a quadratic equation to find the zeros of the function and then solve by factoring. So instead of saying y equals, we're going to say 2x squared minus 3x minus 9 equals 0. So we would try to factor this out. And with the 1.5 that we talked about, negative 1.5, it's not going to be as pretty. Like usually we've talked about whole numbers. But if we know that we're looking for a decimal or a fraction, we can think about that as our possible factors and see if that works. So we want, there's not a greatest common factor. We want a product of 18, because remember, if it's anything, if our a is anything than 1, then we take negative 18. We take our a times c, and we want a product of negative 3. So this is using the grouping method. I'm going to see if you can get, and it should be that our x equals negative 1.5 and our x equals 3. So if you work backwards, because I know it's kind of confusing on how to do that now that we haven't practiced with factors that are not whole numbers. If you are working backwards, so then you know that our factors should be x plus 1.5 and x minus 3. But we know we'll have probably some other things in there. Don't worry about this question. That's really confusing, actually. Look at number 6. Sorry for the bell. Riska found that the factors of a quadratic function of h, or function h, to be x plus 3 and x negative 5. What does this mean about the zeros of h of x? So you should kind of already see it's going to be whatever the opposite sign is of our factor. So zeros at negative 3 and positive 5. Okay. To utilize factoring method to solve the equations, the equation must be set equal to 0. In 7 through 8, first rewrite the equation and then solve by factoring. So when we mean rewrite the equation, I'm just going to show you that part. We're going to just subtract 14 from both sides so we can set that cancels out and equals 0. So x squared plus 5x minus 14 equals 0. That's where you would start factoring. On this equation, plus 5, because that cancels out here. So plus 5 here, because whatever you do to one side, you have to do to the other side. So 2x squared plus 11x plus 5. That is how to factor solving quadratic equations by factoring.